According to the Ampere's law, the line integral of the magnetic field around any closed loop is mu naught times the net current enclosed by that loop. Mathematically, we can write closed integral B dot dl is equal mu naught I, where I is the current enclosed by the loop, dl is a segment of that loop, and B magnetic field is around that closed loop. Like Gauss's law, Ampere's law is used for symmetric cases. In Gauss's law, electric flux is calculated over a Gaussian surface. But in Ampere's law, the magnetic field is summed up over a closed path, which is also called Amperian loop. Mathematically, the Gauss's law is closed integral E dot ds is equal q over epsilon naught. And mathematically, the Ampere law is closed integral B dot dl is equal mu naught I. Please remember, in the case of Gauss's law, the closed integral is a closed surface integral. And in the case of Ampere's law, the closed integral is a closed path integral. Now to find the expression for the magnetic induction at any point due to a long straight wire, let's have a look at this figure, where consider a very long straight wire carrying current I, and the magnetic field is produced along this wire in the form of circle. And this circle is in the plane perpendicular to the length of the wire. Direction of the magnetic field in this case can be found by right hand rule, where the thumb is showing the direction of the current and the fingers sweeping around the wire are showing the direction of magnetic field. So in the case at point P, where we want to find the magnetic induction, at that point magnetic field is tangential to the loop, and at point P, dl, a small segment, is also tangential to the loop. So both magnetic field and dl are parallel to each other. So now by using the left hand side of equation 1, we can say closed integral B dot dl is equal closed integral B dl cos of 0 degree. And that's the angle between B and dl at this case. So cos of 0 tends to 1. So because magnetic field is uniform at each point on the field line, so we keep that outside of the integral. And the closed integral of dl means the integral of element which will form the whole circle of the circumference, and that is equal to 2 pi r. So now equating equation 1 with equation 2, we get B is equal mu naught I over 2 pi r. It shows that the magnetic field at a distance r from a long straight wire carrying the current I. So that's all for the today's lecture.